Now let's look at examples where we're given information about a line and we use that information to write the equation of the line in slope-intercept form. Okay, and I'll remind you the slope-intercept form of a linear equation in two variables is y equals mx plus b. And usually when we're asked to determine the equation of a line, we write the answer in slope-intercept form. It's very common to do that. One, because the equation is solved for y, and two, because it's a useful form of the equation. Okay, so let's consider our first example here. So our first example is a rather basic one, but it's just to help us out. Determine the equation of the line that has a slope of -3. In other words, m is -3. And a y-intercept of 0, -5, that tells us, since it's a y-intercept, that b is -5. So the answer would simply be y equals mx plus b, or y equals -3x plus -5, or just -5. And that's all there is to it. Okay, so let's try some harder examples. So here we want to find the equation of the line that's parallel to this line and that passes through this point. Okay, so let's analyze what we can get from both of those pieces of information. So we first know it's parallel to this line. That means we have the same slope. Well, the slope of this line, since it's in slope-intercept form, is 3/4, which means that our slope is also 3/4 since we're dealing with a parallel line. That's good information. It also passes through this point. Since the x is 0, this is the y-intercept. You can imagine if you were to plot this point, it would be on the y-axis. And since it's the y-intercept, that means that this number here is our b value. Now they didn't tell us this time that this is a y-intercept. They phrased it differently and just said it passes through this point. But since the x is 0, we recognize that this is the y-intercept, therefore b is 1. So the answer is y equals mx plus b, where m is 3/4. So we have y equals mx plus b, which is 1. And that's the answer to this one. So again, not terribly difficult. They just didn't give us the slope directly, and they didn't give us the y-intercept directly. Okay, so now in this example we're getting a little more difficult. We need the equation of the line that's perpendicular to this line and passes through this point. Okay, so let's start with this line. The slope of this line is 3/5. We're perpendicular to this line, so the slope we want is the opposite reciprocal. The opposite reciprocal of 3/5. So in other words, we need to flip 3/5 over to get 5/3. And instead of being positive, we need negative. So there's our slope now. And then we look at this point. Oh, it's worth mentioning, the -7 part here has no effect on what, we're not using that information at all. Because when two lines are perpendicular, all that helps us with is slope, nothing else. Okay? So this is unnecessary information. We don't need it. Sorry, I do know how to spell unnecessary. Sometimes my hand doesn't cooperate. You could probably relate to that. Okay, now we get this point here. Since x is not 0, as it was in the previous example, this can't be the y-intercept. So this problem's a lot different. We don't know our b value. We don't know b. So somehow we have to figure it out. We know our slope, okay? So what is this useful for? Well, what this is useful for is this is an x and a y value. An ordered pair is always an x and a y. And you could do the previous example the exact same way. You should try it out on your own. But these are x and y values. Now, x and y can change because this could have been any point on the line. So 2, 1 could have been any point on the line. But it would still give us an x value and a y value. So if we look at what we have now, we have an x value, a y value, and an m value. And if we look at the equation y equals mx plus b, there are four variables, y, m, x, and b. M and b, remember, are constants, but we don't know b in this case. So what we do is, we don't know b, but we do know the other three values. So what we do is we plug in the three known values and solve for the unknown. Okay, so I'm going to plug in 1 for y. I'll plug in -5/3 for m. That's multiplied by x, which I'm going to plug in 2, plus b. And now I need to solve this equation for b. So let's multiply -5/3 times 2 first to get -10/3 plus b. And then let's add the -10/3. Let's add +10/3 to both sides to finish getting b by itself. So we have 13/3 equals b. So b is 13/3. Good, so now we know our b value. Well, we know our m value also. Those are the two constants in the slope-intercept form, m and b. So m is -5/3, b is 13/3, so the answer is y equals mx plus b. So y equals -5/3, which is m, times x, plus 13/3, which is b. Notice that y and x are the variables, okay? They can change, so y and x are variables. M and b are the numbers, the constants that we had to figure out. So this is our final answer. You don't actually plug in values for y and x in your final answer because there are lots of different y's and x's you could plug in. It just happened that this 2, 1 was a point that was given to us that we could use. So that example was a little more involved than the previous examples. Let's do one more. In this case, we want to find the equation of the line, and we only know 2 points on the line, 2, -4, and 5, -2. So one thing we know we can do rather easily is determine the slope of this line. So let's determine our rise and our run. The rise, you look at how the y value changes. So if my y value starts at -4 and goes up to -2, that means my rise is +2. And use my x values to determine the run. So if I start at an x value of 2 and I move to an x value of 5, that's moving right 3 units. So my run equals +3. Okay? So my slope is rise over run, +2 over +3. Now I need more information. I've got to determine my b value. I don't know my b value. The b value, or the y-intercept, either one, is not given directly. So we must find it. The problem does give us two xy pairs though. So what we're going to do is choose one of the pairs to represent x and y. So it doesn't matter which one we choose. It doesn't matter which one we choose. We will get the same b value because both of these points are on the same line. So the b value is constant. It doesn't change. So let's use 2, -4. It's the first one. Let's use that. So x is 2, y is -4, and m is 2/3. So if we take y equals mx plus b, I can plug in -4 for y, I can plug in 2/3 for m times 2 for x plus b. Now I can solve for b to finish the problem. So to do that, I need to multiply the 2/3 by the 2 first to get 4/3. Copy down my -4 plus my b. Then I'll subtract 4/3 from both sides, and I'll get -16/3 when I subtract 4/3 from -4, and that equals my b value. So now I've got my b value, which is -16/3, and my slope m is 2/3. So the answer is y equals my slope m times 2/3 times x plus my b value, -16/3. Okay, so one more layer here in addition to the previous problem. They didn't even give us the slope. We had to calculate it first, and then we could use one of the ordered pairs to calculate the b value. You should, on your own maybe, try, let me see if I can find a place to type this, maybe try using the other ordered pair, which was what? 5, -2, to calculate b. It should be the same. Okay? All right, so there are many examples of determining equations in slope-intercept form given a variety of different combinations of information. And there are many other types of questions I could have solved too. These are pretty standard types, so I feel like they're a good representation of how you can use this information to get the equation of a line.